Hello everyone, you're welcome to Glen Minds. My name is Ehimwa Sylvester Osemudiame, popularly known as CV. Don't forget to send a mail to me if you have any question at glenminds@gmail.com. You can also join us on Facebook at Glen Minds also. Now, before now we did some stuff and I was able to spot some mistake. Oh my god. It's good to correct mistake, eh? I'm sorry about that. Here comes the mistake. We said 10 plus 9x 1100 minus 100x. I guess we brought this one down to this side. This is supposed to be plus. Who was my teacher? Okay, just joking. So at the end of the day, we're going to get 109x equal to these subtracted from this 1090. So we divide both sides by x. Right? Let's take it again. This comes down to the side, it becomes plus this, and this is 1, this comes to this side, it becomes minus. So 109 divided by this 109. At the end of the day, we're going to get x equal to what? 10. Pretty simple, right? So we're going to go into some of the examples that we have today, and we're going to solve more problems. Now, we have log 2y minus 3 plus log y base 2 equals 2. I want to find the value of 2. Pretty simple, right? Let's see how it goes. Now we have log 2 y minus 3 times 2. So at the end of the day, we're going to have log this times this is going to give us 2. Y equals 2 is going to give us 2y, and this times this will give us minus 6, then equals 2. This is in base 10. Don't forget the relationship. Take this and say 10 raised to the power 2 equal to 2y minus 6. Collect the like things. We have 100 equal to 2y minus 6, which is as good as writing 2y or 100 plus 6 equal to 2y. So we now have 106 equals 2y. Then we divide both sides by 2. By so doing, we're going to get y equal to 53. Pretty simple, right? Y equal to 53. Ladies and gentlemen, we're going to take one more example, and after that, I guess we'll close up the series of logarithm equation. And now it's time for us to solve simultaneous equation. I know everybody really wants to know simultaneous equation. Everybody wants to solve simultaneous equation. But trust me, I'm going to make it very simple. So let's take an example on the simultaneous form of equation that has to do with logarithm. Now let's assume we have log 27 base a plus log 4 base a equal to 5. Let's call that equation 1. We have log 27 base a minus log b 4 and we said equal to 1. Pretty simple, right? Now we're going to watch out for this and see how we'll be able to solve this. Okay, this is equation 1 and this is equation 2. Pretty simple, right? Now we can see that we're having the same base here. We have the same base here. This is b, not a. This is b, and this is not a. We can solve with method called elimination method. I know you must have been taught this in your previous class. So we can solve this using elimination method. Now, using elimination method, we're going to have these and these. When we add these and these together, definitely we're going to get something which is equal to 0. So let's add together in order for us to be able to eliminate log a, which is as good as writing x plus x, and that will give us 2x, right? So we're going to have the same thing here. We're going to have 2 log a 27. Then this is going to give us 0. That's like 4 minus 4, which is 0. That was equal to what? This plus this is giving us 6. Whatever you do to Peter, do it to Paul. That means whatever you do to the left hand side, you do it to the right hand side. So we now have log 27 base a. So let's just go on and just take this thing off so it looks like something that we should know. Now this is going to be log a 27 raised to the power divided by 2. I can divide both sides by 2 because I want this guy to get out of here. So I have log a 27, I have 3, then when I come to this side, take this off, a to the power 3 equal to 27. This is what we already know. Now, what will I do now? I'm going to cube root it. I can do two things. The first one, I can as well say that a is equal to cube root of 27, and that will give me 3. I have the value of a to be 3. Now, let's say the value of b. Let's pick an equation which is quite friendly. Let's take equation 1. Let's consider 1. To consider 1, we're going to have log a 27 plus log 4 equal to 5. So we're picking the first one, which says that a equal to 3. So this is going to give us log 3, 27 plus log, this is in base b. So b 4 equal to 5. And this will give us, you know what this will give us? Guess what? It will give us 3. 3 times 3 times 3, that will give us 3. You know that, but just let me express it for those of us who might not really understand that concept. So we're going to give us 3 raised to the power 3 plus log 4, log b 4 equal to 5. Now, we're going to have this comes out to the side, log 3 base 3 plus log b equal to 4 and equal to 5. 4 equal to 5. Imagine if I'm talking this way, so scary. Okay. This is taking itself out. This becomes 3. Then we have plus log b. We have 4. This is equal to 5. Then we'll take this and say log b, log 4b equal to 5 minus 3. And that is as good as writing log b equal to 2. Oh my word. Here we come. We're fast approaching that answer that we'll be looking for. So log 4 base b equal to 2. And let's see how we'll be able to express that and continue from this other part. Okay. I guess you're finding it interesting. It's quite interesting to solve simultaneous logarithm equation. So we're going to have these. I'll say, okay, b to the power of 2 equal to 4. Don't forget, from log a b equal to x, that a to the power of s equal to b. Pretty simple. Remember, recall, or whatever. Okay, we're going to have b root 4, and that will give us b equal to 2. So we have a equal to 3 and b equal to 2. Ladies and gentlemen, we'll come to the end of the section, the logarithm equation. I hope to see you in some other class. Don't forget to share these videos with your friends. Thanks for watching. I remain Civic. Bye for now.